Hello. In this video, we will practice using inverse trigonometric functions and solve equations using them. You should recall that when evaluating trigonometric functions, the input is an angle measure and the output is a ratio of side lengths. Therefore, when evaluating the inverse of a trigonometric function, essentially the mathematical opposite, the input is a ratio whereas the output is an angle measure. This will be particularly useful for solving for missing angles of a triangle or an unknown angle of rotation that would satisfy certain parameters. Let's start by evaluating several examples with our calculator. For these examples, I would like the results of the angle measure to be reported in degrees. So I need to check the setting on the calculator. This calculator is set to evaluate trig functions with angle measures in degrees. Secondly, it's important to note the syntax, or the order of operation. To evaluate the inverse of cosine at the square root of 2 divided by 2, we must evaluate the square root of 2 divided by 2 first, leaving the result in the calculator, then press the second function command before selecting the inverse cosine button. This result implies the angle 45 degrees has a side length x divided by r ratio of the square root of 2 divided by 2. But so does the angle negative 45 degrees. We should be aware of this while considering the possibility of another angle whose x value is the same as the x value of the 45-degree angle in standard position. Here's another example. The tangent inverse of the square root of 3 would be evaluated with this calculator by first determining the square root of 3, then evaluate the result in the tangent inverse. We see the result is 60 degrees. But the angle 60 degrees larger than 180, or 240 degrees, will also produce a side length ratio equivalent to the square root of 3 in a tangent function, since the y value and x value are both negative in this quadrant. Thus producing a positive result when divided. At this point, it's worth noting the mnemonic phrase, all students take calculus. This will help you to remember which trig functions evaluate to positive values in each quadrant of the coordinate plane. The letter A stands for all trig functions are positive in the first quadrant. The letter S stands for the sine function, which is positive when evaluating an angle measure from the second quadrant. Tangent and cosine, therefore, would compute to a negative result when the angle is in the second quadrant. The letter T stands for the tangent function, which is positive when evaluating an angle measured from the third quadrant. And finally, the letter C stands for the cosine function, which is positive when evaluating an angle measured in the fourth quadrant. Now, when we evaluate sine inverse at the negative square root of 3 divided by 2, we should expect an answer in the third and fourth quadrant, since these are the quadrants where sine is not positive. The calculator shows us a result of negative 60 degrees. The angle 60 degrees beyond 180 degrees, or 240 degrees, or perhaps negative 120 degrees, will also produce a sine result equal to the negative square root of 3 divided by 2. Please try the last example on your own. Pause the video now and resume playback in a moment to check your work. In the next few examples, we can use an earlier definition of our trig functions. Since the side length opposite of the missing angle and the hypotenuse are provided, we should use the inverse of sine to compute the missing angle theta. The value of theta, therefore, computes to approximately 19.47 degrees. In the next example, we should use the inverse of tangent, since the opposite side length and the adjacent side length are provided. Therefore, the angle measure would compute to approximately 30.26 degrees. You'll notice that in both of these examples, I did not bother to find a reference angle that also satisfies the inverse trigonometric function. This is because often the secondary angle won't satisfy the physical constraints of the diagram. In the last example, I'd like for you to try to sketch a diagram based on the following description, then solve for the missing angle using the appropriate trig function. Pause the video now and resume playback in a moment to check your work. With an adjacent side length of 6 and a hypotenuse length of 40, the cosine inverse determines the angle measure is approximately 81.37 degrees.